Well, I think we'll go ahead and get started. Good afternoon, everybody, and welcome to the Exemplary Buildings Optimizing Domestic Hot Water Systems training. Thanks for joining today's session. Sorry we're not able to deliver these trainings in person, but as the COVID-19 pandemic continues to wax and wane, we're probably best served exploring this virtual environment. This training is part of HDC's Exemplary Buildings program, and the second in a series intended to help build capacity in the affordable housing community for delivering exemplary buildings in King County and across Washington State. I want to thank our sponsors, the Bullock Foundation and Edwards Mother Earth Foundation, for their generous support of the Exemplary Buildings program, making this and so much other valuable capacity building work that's going on to be completed over the last couple of years. Today's session is going to be presented by myself and David Reddy, who's a principal with O'Brien 360 and leads the building performance team and has been a really active participant in the Exemplary Buildings program, a kind of key proponent of a lot of what we'll be talking about today. Also want to thank Lauren Tierney and Nathan Antonio with HDC and Emma McKay with O'Brien 360, who are supporting the training behind the scenes. Our learning objectives today are to identify the opportunities to improve domestic hot water system efficiency, to understand the value of integrated hot water system optimization in multifamily buildings, to recognize the primary barriers to optimizing hot water systems and define the process steps to help avoid those barriers to the greatest extent possible when we're optimizing those systems. Those of you who are on Tuesday's training will recognize this slide, but I decided to switch out the appetizer for today. I thought that dim sum was an appropriate choice for a session about hot water. So this session is a high-level view of the options for optimizing domestic hot water systems in affordable multifamily buildings, focusing on the process management that supports change and avoids potential pitfalls. The session will also be available as an asynchronous learning module for project teams to watch on demand. It's not primarily a Q&A session. If you have clarifying questions, please put them in the chat and Emma will call attention to them and we'll get those answered. If you have more substantive questions, you can drop them in the chat, but we'll put them in the bike rack and address them later, as I'll discuss in a moment. The Exemplary Building Program Guideline for domestic hot water is currently in development, but will be completed before the end of the year. It'll provide a more detailed view of system characteristics, design and specification details, and most importantly, the Exemplary Building Program recommendations, which are a rule of thumb that'll suit many projects in our market. Keep an eye out for that publication and do read it when you can. Office hours. So once again, for this session, we are including office hours follow-up sessions. These are live Zoom Q&A sessions with the presenters. Since the Domestic Hot Water Guideline is not actually available yet, we'll likely do a first office hour session in mid-December to answer any follow-up questions that arise from this session, but then do another one a couple of weeks after the guideline is actually published. Those sessions will also be recorded and made available, and there'll also be a written transcript of the questions and answers available. And finally, once again, through the generous support of our sponsors, HDC is also able to provide some additional technical support to help answer those tricky questions that you may come across to need answers to move you forward. But to be clear that we're not able to provide technical support with the design component. For that, you need to hire your own consultant. So, the Exemplary Building Program is a response to climate change. Electrification of domestic hot water systems is a vital step towards our state and city goals for reducing our greenhouse gas emissions to zero by 2050. Every building we build that uses fossil fuel for water heating is taking us away from that goal. The greenhouse gas emissions from electricity generation will be reduced to zero based on the state's clean energy plan. Emissions from burning gas will always be the same. And the total climatic impact of natural gas is, in actual fact, going up as we better understand the impacts of methane in the atmosphere. Over a 20-year cycle, raw methane is 80 times more impactful on the climate than the carbon dioxide, which is released when it's burned. As you'll know from the COP26 gathering recently, the world is increasingly focusing on the importance of methane controls as an urgent priority in order to stem the rate of climate change. Since we're placing more load on the electric grid by turning away from gas boilers, it's also important to make these systems as efficient as possible so that access to renewable electricity generation can keep up with the demand. In addition, domestic hot water demand is closely aligned with the grid demand peaks, which generally have higher carbon emissions than base load. Systems that can shift water heating energy use away from those peak times will also have less burden on the system and lower the overall carbon emissions. One downside of some heat pump water heating systems is that they use refrigerants with very high global warming potential, sometimes thousands of times the impact of CO2. And while those refrigerants are not consumed or intentionally released, they can escape by accident. So there's good reason to install systems with the safest refrigerants that are available. Our agenda today will focus on context. We'll do some level setting. We'll look at state and local code requirements and where they're headed. And we'll touch briefly on where Evergreen Sustainable Development Standard version 4 stands in terms of mandatory requirements and options for domestic hot water. We'll then look at opportunities for optimization, looking at both efficient distribution systems and efficient electric heating systems. We'll look at process steps and pitfall avoidance, and we'll end up with a little reflection and synthesis so that we can gauge where you as an audience are at and see how best we can identify ways to help support you and continue to build capacity through this program. So let's start off with some level setting. What do we know about multifamily water use? It'll come as no surprise, I hope, to most of you, that water and sewer fees are generally a much larger component of your utility cost than any other utility. And yet residents have no idea how much water they consume or how much it costs them. High volume consumers pay the same as low volume consumers. And while we all talk about energy efficiency as a future-proofing measure, protecting us from volatile future energy cost markets, water and sewer rates are actually rising at a faster rate than electricity rates. In addition to consumption costs, the cost of service hookup can be substantial. System development charges, like an impact fee, can run to tens of thousands of dollars in upfront costs, as can your connection charge and your utility meter installation charges. All of these are driven by service size, and service size is driven by traditional plumbing specifications that don't recognize efforts to reduce water consumption, such as low flow fixture performance and Energy Star appliances. 40% of the water consumed in multifamily buildings is hot water. The energy we use to heat that water is a significant component of total building energy consumption. Under the 2006 Energy Code, it was roughly 35% of the total energy consumed by the building. In 2018, because code updates have reduced other loads in our buildings, but not the domestic hot water loads, it actually increased to about 40% of the total. This makes this the biggest target for energy efficiency improvements that we need to make between now and 2030. Okay, so now let's find out what else we know about hot water in multifamily buildings. I'd like you to answer these three questions. What percentage of the heat, we're talking about multifamily buildings with central hot water systems here, what percentage of the heat energy that we put into the water at the water heater actually comes out of the shower head? Second question, in a typical multifamily building over a 24-hour period, how many hours have 0 hot water draws? And the third question, for you personally, what's an acceptable amount of time to wait for hot water in your shower? Now, we're going to jump over to a whiteboard on Mural to answer these questions. Emma's just pasted a link in the chat. If you click on that link and follow it, it'll open a browser window. And the 3 questions are set up here. Essentially, for each one, I'd like you to grab a dot and drag it into one of the boxes that represents your response. We're just going to take about a minute for each of these. Starting to see people showing up. It's taking a few people a few minutes to get in here. Okay. I'm going to hide people's cursors. Just makes it a little less busy. This is good. Seeing 16 people online. And that, we've got 22 altogether. So most of you have managed to find your way here. And most of you seem to have voted already. That's great. Good. Activity seems to be dying down. So the whiteboard will stay open. So you don't change your choice, but let's go ahead and take a look at the answers. Okay, so how much heat gets to the shower head? Well, if you answered 60% or 50%, you're right on the money. Roughly 40 to 50% of the energy used to heat the water is actually lost in the distribution system. One of the reasons to really focus on distribution as well as just on equipment efficiency. I think the thing that's impressive is that that's actually 5 to 10% of the total multifamily building energy consumption, which is pretty significant. I think it's also interesting to note that while it does help heat the building, that heat is being lost inside the building. So it does help to heat the building in the winter, but it's not really putting the heat where you want it. And it does also add to the cooling load in the summertime. So as we're increasingly wrestling with how to keep buildings cool during our high temperature events, the fact that we're losing a lot of heat from that 120-degree loop is pretty significant. How many hours have 0 calls for hot water? And the right answer was actually 0. Let's see, we had a pretty good spread on that one. Yeah, so the reality is that in most buildings, we're actually seeing almost no time during the day or night when someone somewhere in the building doesn't turn on a hot water fixture for one reason or another. And then question 3. How did we do on that one? Just want to step back there for a moment. So most of us were in the 20-second category, a few of us in the 30-second, only a couple of impatient souls who were down at 10 seconds. The reality is that according to the American Society of Plumbing Engineers, 1 to 10 seconds is what we should call acceptable performance. If we're between 11 and 30 seconds, we're actually in the marginal category. If you have to wait more than 30 seconds for hot water, you're likely going to walk away and do something else, letting the hot water just run straight down the drain. Evergreen version 4, criterion 4.06, requires a half gallon of water in the pipe between the recirculation loop and the fixture. So if you have a 1.5 gallon shower head, so a low flow shower head, you're going to wait about 20 seconds for hot water. That's where Evergreen sets the bar. The good news is that getting the stored water volume in a pipe down to or even below that half gallon just really takes a little care and attention. Here's an example with 2 stacks of units served off a common riser shared between the 2 units, with the plumbing runs with PEX piping across to the bathrooms. And then on the reverse situation with the bathrooms on the interior walls together, you can actually see it improved even more. So now we're all on the same page about how our hot water systems perform in our buildings. I'm going to turn it over to David to explore how we make them better. So I'm going to stop my share, David, and pass it over to you.
Great. Thank you, Alistair. Yeah, those numbers are, it's cool to see the survey data on the shower delivery time, especially. I was really interested to see that. That informs our guidance for the Exemplary Building Program. So I'm going to speak today about, start with the context of a couple of the topics we're going to talk about. One of the most commonly asked questions I get in working with teams is, what's the code now? We all know we just changed 2018 Energy Code in Washington and Seattle. They were delayed. There are pretty substantial differences this year with this code cycle between Seattle and outside of Seattle. So just wanted to kind of address those up front. In Seattle, as most people I think know now, heat pump water heating, using heat pumps for water heating in central systems is required starting beginning of next year. So that's a really dramatic change. And as Alistair pointed out, it has the potential to reduce building energy use by a lot. However, outside Seattle, it's not yet required. But that's not what that does mean is an opportunity to meet the prescriptive kind of optional C406 section of the code with credits. And also it also means that utilities will give you money to do this, whereas they wouldn't in Seattle because it would be required. So it's still an excellent opportunity. And as far as I know, King County has proposed legislation. It's not yet adopted, but it includes rules that will apply to unincorporated areas that are very similar to what Seattle has. Again, requiring heat pump water heating. And Bellingham, my understanding, is also on that road as well. So this change is happening. It's spreading out, and actually in the Energy Code tag process that's going on now for the 2021 Washington State Energy Code, it will include rules very similar to what Seattle has for multifamily buildings requiring heat pump water heating. And that would become effective in July 2023. So statewide, this measure that we're talking, one of the measures we're talking about would be required as well. And, you know, the other thing to point out is similar to the incentives is doing these things can oftentimes bring you points in your ESDS scorecard. And so I think there's a lot of symbiosis between the two, these exemplary building recommendations and a lot of the things that you need to do for code or ESDS. So today, you know, Alistair mentioned the guidelines that are forthcoming. Those guidelines will include recommendations for a number of different areas. from plumbing fixtures to water heating plant design. Today, we're going to focus most on two areas. The first one I'm going to talk about is optimized pipe sizing and distribution, and then metering and monitoring. We'll have a little case study on that. I'm going to start with an overview of the recommendations for all of the areas, just quickly go through that, and then dive into the pipe sizing. So in plumbing fixtures, we're recommending WaterSense certified. That's actually already part of code and ESDS. The flow rates we're recommending are a little bit lower than code. They are 1.5 GPM for a shower head, 1 GPM for faucets, with the recommendation to use what's called a spray pattern aerator, as shown in the picture. Kitchen faucets, 1.5 GPM with a boost for cleaning dishes. And toilets is an area that I feel have come a long way. There's a lot of examples of really successful installations, a retrofit even, of low flow toilets, lower than what's required by code or ESDS in the 0.8 to 1.1 gallon per flush range. What Exemplary Building Program is trying to encourage is that you choose toilets that are considered what is called MAP Premium. MAP is a testing agency for toilets. They have a scale, ranges from, I think, 500 to 1,000, and those numbers are corresponding to grams of what they actually use to test, which is miso paste. They flush grams of miso paste down the toilet to test how good they clear. And a MAP Premium toilet is rated to flush 28 ounces of miso paste, which is, if you're familiar with miso paste, this one of these buckets down the toilet in successfully. So they are quite the performance is quite good on these well-designed toilets. So we feel comfortable and confident that teams should start looking at them and using them if they're not. This is just an overview of all of them, showing code before middle of last year. And we had a very large change in code and reduction to things that were already happening in the market and in ESDS. And that's why ESDS mandatory requirements are pretty much aligned with code now. And there's just a few points available for toilets and shower heads going lower. And the exemplary building recommendations are pretty in line with those points as well. So just, again, going for high performance toilets, use that MAP resource to evaluate them. Appliances, we speak briefly, just recommending using dishwashers for larger units, enclosed washers and the even larger ones as a convenience for those tenants. But generally, central laundry is going to be more efficient than in-unit laundry, lower cost, lower maintenance. So, choosing that, making that decision wisely, and definitely encouraging cold water washing. I mean, that reduces your hot water peak loads that we're going to talk about, our total loads. And so really is a common sense measure that if we can get as much of that happening, even the high efficiency commercial washers in a hot cycle actually use just a couple gallons of hot water. But it's still, the detergents are acceptable at lower temps now. So the guidelines speak to metering. Our recommendation is hot and cold water submetering. This is common practice for a lot of developers already. And most of those have learned that the data has been extremely useful in guiding, understanding where water is being used and also intervening if necessary. As Alistair mentioned, in most of the affordable housing projects, water is not billed to tenants. There's an owner cost. And so if there's a way to reduce the energy use by working with tenants that are high users. The only way you can do that is with metering. SHA, Seattle Housing Authority, actually uses metering to bill tenants, or not directly bill necessarily, but give everybody an allowance and give credits and debits based on if they exceed a certain amount. And but what we have learned in helping teams implement metering and commissioning is that the meters are only as useful as if they work and are reporting the data accurately and for the right units. So, and unfortunately, just with the flurry of things happening at the end of a construction builds, metering is not oftentimes number one at the owner's mind, and it can, if this isn't kind of followed up on to make sure it's been commissioned properly, it's really hard to determine if there's a problem later without going in every unit and doing a lot of testing. So monitoring, what we are recommending is definitely installing a monitoring system. Monitoring systems aren't technically required by code if you do central systems, but these meters only work if you have the data, and we think it's important that they have alerts for certain criteria. Whether it's low levels of consumption that would be associated with leaks, leaking toilets, they can see that in the data, so to speak, or no consumption. If there's a long period of no consumption, that could be a red flag, or maybe it's just a broken meter. And then also on a shorter basis, daily at the very longest, some kind of alert that there's an equipment failure on the transmitter generally, or a high consumption, so a very large amount of water used. So, and then storing data over time is a really important aspect. This is an area we're going to delve into a lot. So, the recommendation here is to use the most current, modern, informed pipe sizing method for hot and cold water and main distribution connection to the utility for sizing all those pipes. That's the 2018 UPC Appendix M. And again, I'm going to dive this in real deep, so I'm going to go quickly here, but reducing risers by running plans back to back. I see most teams are already doing this inherently, although there are, in most all projects, I always see a few opportunities that with just a plan configuration, a mirroring of one or another, you can reduce yet another one or two risers. So still work to be done there. Laying out the unit plumbing. So this is our recommendation, and this is kind of aligned with that survey question Alistair had, which is we're recommending aiming for 15 seconds and on your shower head specifically, because the shower head is what we feel is the most important fixture to kind of reduce that delivery time of hot water, and to do this without recirculating hot water all the way into the unit to the unit manifold, which is something I have seen in an act of, I guess, whenever the risers can't be situated or there wasn't advanced work to make sure risers could be located close to a good place for the manifold. And then to achieve a fast delivery time, they put in this extra recirculating loop and balancing valve. And it just, in my mind, it's not worth the extra cost and maintenance and energy use to do that. So just avoid recirculation at that level. And then lastly, to insulate pipes with more insulation, we're adopting actually what is already in the Seattle Energy Code with 1 inch more insulation than what has been required in the past. So, again, to reduce hot water loads, try and address, all these things address that big number that Alistair mentioned, up to 50% of the energy just being, lost through the circulation system, and trying to address that problem. water heating plant design, we touch on in the guidelines, and our fundamental recommendation is to use air source heat pumps, reduce energy use. It's a huge measure. And we have the technology available today. And to do that with any kind of backup heating, to use electricity to do that, whether it's another heat pump or electric resistance, even if a properly designed system, we can, and doing these optimization of the distribution, that energy is not, there's not as much energy used for temperature maintenance, and therefore using electric resistance is a reasonable, less maintenance, lower cost way to do it. There is a new water heating specification that NEA, the Northwest Energy Efficiency Alliance, has developed that now includes central water heating, heat pump water heating systems. So that's a nice guide for what teams should be including in their designs. And to use low global warming potential refrigerants in those heat pumps. And those are mainly CO2, and another one, R515, which is Nile is one manufacturer that's using that. These are not as many heat pumps available that use these low GWP refrigerants, but there are more coming. And especially CO2 heat pumps are very well suited to heating hot water. So it's a natural fit there. And, this is something that we haven't yet found being emphasized enough in embarking on this journey to use heat pumps. And that is to provide this designers with good estimates for their sizing. We'll talk a little bit later. There's a tool used for sizing heat pump systems that's long-awaited and really useful, called the EcoSizer. However, the EcoSizer relies on having knowledge of how many people that system serves and what their expected daily water use is. So those are inputs that designers need, and they may not have asked for in the past. And we really want to encourage that teams work with their designer to make sure that they have these assumptions dialed in, because it can result in too many, very costly systems because they're being too conservative, or, worst case, there's not enough heating capacity in the system because this was not, the teams weren't on the same page with what the expected building use was. So, and then lastly, demand profile. We'll talk a little bit about that. That can affect sizing, and I'll have some examples. So we're not going to dwell on this. It's a really interesting topic, but there are a lot of resources. I mentioned the water heating specification that's on the web. The Lighting Design Lab has produced a multi-part, various, it's competing with Star Wars in terms of the number of training sessions available. And I highly encourage them. They're excellent. I've reviewed almost all of them at this point, and there's just a ton of great information. Ecotope is leading those trainings, and they're really well done. So I just encourage, watch those and then come back to our guidelines for some additional recommendations. I mentioned EcoSizer for sizing tools. All designers should be using this, at least as a starting point. And next year, I believe Ecotope and utilities will be coming forth with what's called EcoSim, which is a tool for actually doing the modeling, where teams like us are currently using our own models. And so why should we use heat pumps for water heating? I mentioned how much energy they save. Obviously, it's one of those things that is a huge impact measure. We can do it today. We can get to our 2330 goal with one step, almost one step, just by this measure. Mentioned the C406 credits, and for teams that are designing buildings that use tax credit or bond funding, this system is worth a ton of ESDS 5.2 points, And it is definitely a good way to be very competitive if you just do that one measure, honestly. And it's as I mentioned, the utility incentives, we see anywhere from $500 to $800 per unit on the table. So that makes it cost effective, especially if we combine it with some of the things we're going to talk about with pipe sizing. And then, one of the things that is not at people's front of mind, I think yet, is that, over time, we do expect natural gas rates to go up faster than electricity. This is the Department of Commerce's projection for the difference in escalation over time. And you can see right around 2030, which is right also around the time when we have some very, strong statewide efficiency goals on our grid, that natural gas is expected to get more expensive and continue to go up. So anticipating that and using heat pumps now can kind of insulate you from those increases. And then also, as the grid gets more clean, which is already part of our commitment, at least for Washington State, is you can take advantage of that clean electricity and reduce your overall emissions. Whereas if you put in a natural gas system today, you're kind of locked in for quite a while. And for people who might be looking at rehabbing buildings that use natural gas for water heating or space heating, they start to learn it's very difficult to get away from that because of electricity capacity at the site. So just something to keep working, making decisions now can lock you into lower costs and lower emissions in the long term. So we're going to drill in pretty deep with a lot of examples of the why we should be focus on optimizing pipe sizing distribution. And we're going to do a comparison between the sizing method for two projects, the Exemplary building demonstration projects, that if you were with us on Tuesday, you will recognize these, Hobson Place South and Saguaro. Two very different building occupants, unit sizes, unit mix, but fortunately, the teams involved with these projects and also with support from the Exemplary Building Task Force have been able to do some comparisons between these different sizing methods for these two projects. So just an overview of the two, again, 92 units for Hobson Place South, permanent supportive housing. Saguaro is a SHA workforce family housing, 114 units. And if a plumbing engineer looked at these two buildings and used, kind of the default or conservative or, code accepted, tried and true, pretty much was standard practice up until, even recently, you would be sizing this building to require a main connection to the utility of probably around 4 inches for both buildings. And with Saguaro being very close to meeting the next pipe size. The Uniform Plumbing Code has some appendices that, including one that allows you to account for what are called bathroom groups and just a way to refine it a little further and reduce which results in reducing your expected peak GPM or gallons per minute demand of water for the site. And that translates to a reduction in main size as well. Further, 3 inches for Hobson, and now we're still probably 4 inches for Saguaro with that sizing method. The UPC Appendix M, which we're recommending and is in the code, the 2018 plumbing code, would result in 80 to 90% reduction in that peak GPM estimate, which is dramatic in terms of pipe sizing. The main size required for these two buildings goes down 2 sizes or 2 or 3 sizes here, depending on the utilities increment. So this is a dramatic reduction, and can, I'll show later, can save a lot of money. This is another way to look at the different methods. And, you know, for Hobson, we're looking at going from the 3 to a 1 inch. One thing to keep in mind is these comparisons were done just looking at the apartments themselves and common laundry or laundry that would be included in the two buildings. It didn't include, you know, community rooms or other things separate from the housing portion, which differs depending on the building, obviously. So these numbers don't include those, but those other uses don't necessarily always translate to, as, you know, the predominant amount of water is used by the residents. So, but I think these generalizations are true for most any multifamily building in terms of the scale of reduction. So how does this compare to reality? And, you know, I hesitate to even say that we need to do this comparison because the method itself was based on actual testing and measurement and refined over time. It's in the Uniform Plumbing Code as an acceptable method for sizing service. And so, but, you know, we have data locally and, you know, why not look at it and see how, you know, does it pass the sniff test? We have two projects that we have data from. There's others, but these are the two I'll focus on because they somewhat parallel, at least the Hobson Place. One is data from the Estelle, another DSC, Permanent Supportive Housing project, and then also a market rate project that was data acquired for as part of doing a heat pump water heating installation. So from Stream Uptown, which is a market rate project, this is the flow profile that Alistair showed you. You know, very few periods of low demand, but you can see this is a very stereotypical load profile, as we call it, for how water is used. A real high peak in the morning when people are waking up, taking showers, less during the day, assuming they go to work, and then another peak in the evening. You know, one thing to see is that it's that peak, the average flow is oftentimes 50% higher. And for sizing systems, we always have to look at the peak. So it's just something to look at. If you have average data, you should think about multiplying that by 1.5 to understand what your real peak is. And it just so happens that this profile is very similar to the one that the EcoSizer, the tool that's used for sizing heat pump systems, uses. It looks very similar. It's something to understand when it looks at load shifting or sizing storage volume. This is the profile that's built in, the design day profile, and so that can have an influence on sizing systems. But now moving over to Estelle, this is data that was acquired from that sub-metering system, and you see a much different profile. Permanent supportive housing, a lot of are residents that are formerly homeless. They may not have jobs. They're home and they're at home more parts of the day. And you can see a very almost uniform or flat load of and use of hot water. And if we compare that again to the EcoSizer profile, it's much different. So just one of the things to emphasize is different buildings will have different load profiles, and something that does influence sizing. Here's two more pieces of data. Again, very low flows per unit on you know, at the peak. The left is Elizabeth James. It's an affordable senior housing project. The right is a large market rate project. But the peak hot water demands are very similar per unit and not that large. So again, this is whole building data. And again, you can see the difference in those profiles. So just to kind of compare how to sum up what the difference is between the measured peaks. So we have, this hot water peak demand of 8 GPM per stream, and using the Appendix M and assuming 50% of the water is hot, it's 9 GPM. So you can see it's very well aligned. And for Estelle, again, the Appendix M would have slightly overestimated the peak, but that's, it gets to that load profile. The load profile for permanent supported housing does not have that very high peak morning, and that's reflected in the data. So the Appendix M would be more conservative for that application. So again, keep in mind that the peak value could be 50% higher than the median or average, and that's important for sizing. So how does this pipe size influence costs besides energy and other things? Alistair mentioned system development fees. There's a wide range depending on where you're connecting to the utility. Seattle happens to have higher rates and lower connection fees, whereas other utilities have higher connection fees and maybe lower rates, depends. But when I started looking at this, I was working on a project in Skagit County. And so I started thinking about the ramifications of connection fees in the context of Skagit versus Seattle. You can see just how dramatically different the meter size connection fees are for the two utilities. More than twice the cost for a 4-inch or 3-inch meter. So you can start thinking about how much you can save by using this new method. And for, in Skagit County, for example, it's almost $750 up an apartment first cost just on that connection. If we look at utilities, also tend to use the meter size to dictate the minimum monthly service charge. And again, those can differ. For a lot of utilities outside Seattle don't have a very large minimum monthly service charge and a very minor or maybe no cost for consumption. So it's all to say that the location is very important, that the utility rate and structure is very important for understanding the savings on the table here. Here's just monthly service charge savings between the two. Pretty significant, especially considering this is per year. So over 50 years, you can start thinking of the savings. And then pipe costs. This is a comparison of using the pipes in the building for the two methods, and just on pipe material savings. So not labor, not fittings, just the length of PEX pipe in the building, saving $55 a unit. And then we go to another phase of optimization, which is reducing those risers. Sawara, if it had used one riser per stack, which would have been I see that all the time on building designs. If by consolidating a few of them and reorienting units, that was reduced to 6 risers for the building, at least a portion of the building. And that was done by locating the riser in a party wall between the two units and coming off that to 2 different unit manifolds and then serving the fixtures from there. And even this design, even with how far the unit manifold is from the shower, for example, would still meet the delivery time target that we're talking about, assuming 1/2-inch pipe from the manifold. So by limiting risers, you can save materials, like the estimated cost per riser that we had from one study was $3,500. And then you save energy too, because the risers make up the majority of the pipe length in the building. The pipe length is pretty directly proportional to the energy lost. And by reduce every riser or going from, for Hobson Place, we estimated a reduction from going from 24 to 17 risers and saving roughly $16 per unit per year. And that's even after accounting for the fact that Alistair mentioned that heat in the riser does dissipate to the building. It offsets some of the heating load. About 40% is what you could use as an estimate of that effect. But it still saves a fair amount of money over time. So this summarizes all the different savings that we're talking about by using this method. It is, it ends up being anywhere from $230 per unit in SPU land, and almost $800 if you go to a utility district that really front loads costs based on meter and monthly charges based on meter, and then the monthly or annual savings for energy and water. So I hope if everybody comes away with one thing, it's a significant opportunity. It's great now that we have the method formally in the plumbing code. I even had an engineer tell me that King County has reviewed this and approved it in the past, and now I understand they're even recommending it. So I don't know the landscape outside of Seattle and in King County yet to know, but I try and recommend it for every project that I'm involved in now. And it is, if it does take some work with the authority, it's worth it, I believe. I would recommend asking your engineer to do it and compare it to how they would have sized it using Appendix A and C, so you understand what you're saving. And then one thing that we already know, or the draft of the 2021 state code is going to include it as an option to get credits for in C406. So I see similar things in California as well. Everybody's recognizing the savings from using this new method. And with that, Alistair, I am going to pass it over to you.
Okay, thanks, David. That's awesome. Lots of good, meaty stuff there. I will get back to my screen, which you should now have. So, yeah, great opportunity. Lots of interesting stuff coming up in the guidelines that are the result of a lot of kind of hard work and research. And the next step is, how do we get there? The savings that David's talking about are really substantial. And yet we don't seem to have moved the needle very far on this distribution conversation over time. So thinking about process improvement and how to get there is obviously a clear next step. So I see I forgot to took my parentheses out of this slide, but as we started getting into the details of this training session, thinking about understanding ideal process flow and where the real barriers were, I began to think that we should have used this as the title: Optimizing Multifamily Domestic Hot Water in 7 Easy Steps and 2 Hard Ones. Some of the steps to optimizing domestic hot water systems seem pretty simple: installing low flow fixtures and using Energy Star appliances. While others are really, or either are or were challenging. Switching from gas boilers to heat pump water heaters until very recently has been seen as a major challenge. Figuring out how to reduce the amount of water stored in the fixture branch, it's met with a lot of resistance. When we did the exemplary building charrette a while ago, I think the process was broken down into something like 14 steps. For this session, we whittled it down to 9. And so the first one, as David's already touched on, is understanding your residents' water use. And we'll come on to talk a little more about that. The second is establishing clear project requirements for domestic hot water performance. And these setting early goals is a mantra for us and a mantra for the Exemplary building program, this early integrative design approach, starting off with clear understanding of where it is you're headed and how you're going to measure whether you're going in the right direction and whether you get there. Then we get to the first difficult step in this process, getting the plumbing engineer on board. Seems to be part of the resistance and part of the challenge, and the market's moved a long way, but this continues to be one of the things that we really have to pay attention to. Once we've done that, we can then focus on optimizing the domestic hot water distribution design. David's laid out very clearly all the tools that are available, all the information that's available, and the fact that we even have a methodology embedded in the code now to get us there means that this should become an easy step. Then we select and specify the water heating equipment. And then we run into the next challenge, getting the plumbing contractor on board. Because even if we have the design established to deliver the distribution system that we want, the reality is that when it comes to the crunch in construction, we may run into a situation where we have a plumbing contractor who just won't do it the way we want it to be done. If we can get over that hurdle, then we can move on to the construction phase, but we still have to make sure that the installers themselves understand the requirements and that there's good quality management and good quality control in construction to make sure that it's actually being implemented the way it was designed. And then we also have to ensure that we do effective performance testing to make sure things are performing the right way, and that we have the time to do thorough commissioning, because these systems do require more time to set up. We were recently involved in a market rate project where the contractor was struggling to get permit sign off from the jurisdiction for their hookup to the city water. And they were pushed up against a deadline for moving in tenants. And there was literally no time between getting the water turned on in the building and moving people in to be able to finish commissioning the distribution system. And so we ended up doing commissioning with tenants already in the building. And that's not a place that you really want to be. Hot water heat pump systems require a little more to get them set up and functioning effectively. So that's a key step. And then, of course, the ongoing operations and maintenance priorities in terms of figuring out how we get the best out of these systems, not just to begin with, but over the life cycle. So that process flow is not so different from where we've been on other energy efficiency measures. These two key components that I'm calling out here as the hard steps are something that I think we have to be really cognizant of. Now that I've upset all the plumbers in the session, although I'm actually not sure whether there were any plumbing engineers or contractors signed up for it, and I wish there were, I do want to clarify where I'm coming from on this. We all know that plumbers make good money, right? So why are they so highly valued? Well, because they provide the most fundamental utility in a building. And potable water is essential to life and health. If they do bad work, it can harm your residents and break your building. So plumbers have to be highly trained and educated. Why do they tend to be conservative and slow to adopt new approaches and new technologies? Well, you read a conventional construction contract recently. Once again, water can break your building. A hot water system that doesn't deliver is a property manager's worst nightmare. Plumbing systems tend to be buried in the building structure, so fixes are costly. If we want plumbing designers and plumbing installers to step out of their comfort zone, we need to show them clearly where we want to go and why, and we need to take our share of the responsibility for getting there. We want to push them out of their comfort zone. We've got to hold their hand and jump with them. So, what do we know about hot and cold water consumption in our buildings. David showed that there is information available and there is a way to get it, but do we know how much our residents in our buildings consume in a day? Do we know when the peak demand periods are, depending on our occupancy type? What's the total flow during those peaks? If you can't answer these questions, you're asking the plumber to take a shot in the dark. So they must make conservative assumptions based on what they've been taught or on past experience. If they aim too low, residents are going to complain instantly. Owners are going to be unhappy. So if they aim too high, no one knows the difference, right? If you've oversized your system, there's no apparent penalty for that because we haven't really been measuring it in the past, but now we're starting to dial it down. So in this situation where there's clear challenge to aiming low, when we ask them to aim low, but there's no penalty to aiming high, what would you do in their shoes? So I think this is a critically important component of the process change that we have to make in order to move the needle and actually get from where we are to delivering buildings with all the features that David's just talked about. We got to know how our buildings perform, and that means metering and monitoring. We've got to understand how our buildings compare so that we can see if we have a building that's anomalous with others or if we're consistent with others. The more information that we have, the more we can drill in to understand the performance of our buildings and to be able to develop a level of comfort and confidence for the plumber to be able to follow the path that you're wanting to set for them. So setting clear project requirements means that we're setting a target for the plumbing engineer to aim at. So with that, I'm going to pass it back to David again to talk a little bit more about water metering and what it can show us.
Thanks, Alistair. Yeah, I mean, excellent points. And I think that there are a number of developers who do install metering and do monitor and have a good sense, but it's still, it's not in the code, for example. Hot water metering is, but there's nothing in the code that requires you to ever look at that data if you, and so it's an area that it's still optional or has to be incentivized, but it can be extremely useful and is really the only way to curtail high users or reduce your bills or properly size your systems. So we're going to talk briefly about a case study. Coming back to one of our buildings that we've learned a lot from, the Estelle. It is permanent supportive housing, so there are some caveats to the conclusions of what we're going to talk about here. But I can tell you that the gallons of hot water per person, which is a metric that is oftentimes used, should be known about for designing your system or knowing how much you're going to spend on utility bills. That number is roughly for all the buildings we've looked at, from permanent supportive to market rate to workforce is around 15 to 20 gallons of hot water per person per day. That number is where things are at, and that's with things like low flow shower heads, which are kind of ubiquitous at this point with ESDS and LEED and other programs that require them. So that number is a pretty solid estimate. And then another rule of thumb is that your cold water consumption per person is roughly double that. So it's roughly split 50-50 between hot and cold. Although some buildings have a little more hot than cold, but those are rule of thumb numbers. However, you should really try and verify these things. And then what we're going to talk about here is how that's the average. And it's really a subset the people that are using a large fraction of the extra water above the average. So it's if you can identify those units and work with them the opportunities to save money as an owner are pretty significant. So you still included hot and cold water submetering. That's their standard at DSC. It's a standard for a lot of developers now. But in this case, the meters were connected to the building automation system to be able to get more granular data, like every minute that we could get reported data. And also it was straightforward, or not straightforward, but it was possible to actually alert facility managers if there was high consumption in real time, like as soon as it happened, rather than a lot of metering systems do only let you know the next day if there was a lot of water use in an apartment. So that was important because they had some issues with flooding, and also it was just some interest in understanding when is water being used and how much, and what can we do about it. And the data shows that it confirmed the suspicion that there's a handful of tenants that were using a lot of water. And even though this is supportive housing, a unique population, we see this in other data sets as well, that there's always outliers. And so those handfuls of units or people were responsible for, roughly 40% of the consumption in the period we looked at, the 3-month period. And this is just another way of looking at it. It's just how much hot water per unit per day at the max that those units were using. So this is really important because also that, we talked about the design load, how much hot water does the water heating system and the pipes need to be able to support delivering at a given time. And these outliers can really influence or affect that assumption. So if we can wrangle them, there's a lot of opportunity for savings. And so here's the average per unit per day. The idea of upgrading the monitoring system to be able to do what we call real-time alerts to let facility managers know when those high consumption events are happening in real time instead of the next day does come with a cost. And it's roughly $200 per unit depending on the system. There are systems available that don't require a DDC, a building automation system. They can just be added onto your water metering system to get that. And it was found, just doing some rough calculations, that they could realize a 4-year payback on that investment if they could just reduce their consumption by 10%. And so it's got a short payback, and it saves that resource. It saves potentially a flooding event, and so it was a pretty straightforward decision. So I mentioned that it is oftentimes a handful of tenants that you would need to work with if you have this data to try and reduce your overall consumption pretty significantly. The automatic alerts are key for some population or for some applications. And what I mean by that is that you get an email or a text, not have to log in and see something. We also learned that setting the criteria for when you get those alerts is really important. You don't want to get an email every 2 hours for something that it just turns into spam. And so you want to have targeted alerts, have a criteria that works well for your application. And that may take some time. That may take gathering data on your building for a while, testing different criteria, and then coming up with what your final metric is. So with that, I'm going to hand it back to you, Alistair. Bring us in.
Awesome. Thank you, David. Let me go back. Yeah. Okay. Okay. So I don't want to belabor this point too much. We're doing okay on time, but I want to move things right along. Essentially, you got to decide where you're headed. You've got to set clear goals at the organizational level. We've got to set targets, performance targets. You've got to have design standards that point to how you want your system to be designed and delivered. You've got to have owners' project requirements, acceptance criteria, all these things in place. Setting these tangible targets early is key. So you can give the plumbing designer, the plumbing contractor, a clear indication of what you want from them. If that's communicated in your DD pricing exercise, then they can decide whether they're in or out, right? And based on how they respond to the opportunity, you can decide whether you want them in or out. Deciding on the right partners is really key, right? You know where you're headed, you got to decide who you want to travel with. So communicate a clear vision of where you want to go. Demonstrate that you're committed to getting there together. I think this is at least in part about trust. This is a fairly hard technical topic, but there's definitely a human side to it. And I think if we're going to get where we want to go, we've got to do it with an element of trust and mutual support. So setting clear specifications. The secret is expanding your partner's comfort zone, right? Not trying to push them out of it. So that's really the key. We got to figure out what's out there. We've got to grab each other and we got to jump together. I'm revisiting the old snakes and ladders again here, just quickly, the same as back on Tuesday. But really, the snakes are pretty clear. If you're not clear on who your building tenants are and how they use water, if you're not clear how you want to deliver that performance, then it's going to be difficult. Making sure that people are on board, and that's the designer, the building official, the contractor, the general contractor, and the subs, because everybody's got to be lined up to make all of this work well. The ladders that boost you through this process quicker are all the things that we've already talked about. So I don't want to dig into that in any more detail than that. But before we go to our little kind of reflection and synthesis session, I do just want to revisit again, because one of the most exciting reasons to focus on particularly this hot water distribution efficiency conversation, which is something that we've pushed for a long time, both in the market rate space and in the affordable housing space, is that this is one of the rare energy efficiency measures that might actually reduce capital costs. We're so used to seeing these things costing more and then having to justify them through paybacks and all kinds of other things. But to a large extent, we're seeing that accurate demand evaluation leads to smaller water heating equipment and storage, and that's less cost, and it's less space. That by right-sizing the distribution, it leads to smaller pipe sizes, less material cost. That smaller pipes lead to smaller meters, so we have another savings. And then smaller meters lead to reduced hookup fees and ongoing service costs. So again, less cost. And then finally, less sewer bills, less water and sewer bills. So it's just a real all positive message. And we just have to get over this relationship challenge in order to get everybody comfortable with getting there together. So just to quickly recap our learning objectives, I think we identified what the key opportunities are to improve the system, both the distribution system and the plant. And we've touched less on the plant because there's so much good information, good training, good information out there now. And I think the whole market is moving in the right direction. I think we've tried to demonstrate the value of this integrated hot water system optimization, what the primary barriers are, and, you know, a process approach to trying to get over those barriers so that we can actually move this ball down the field fairly quickly. The evaluation that comes out following the training will give you an opportunity to let us know whether you feel we've addressed these learning objectives effectively. But what I would like to do now is to jump again over to another whiteboard. There should be another link now in the chat for you to jump over and hear the questions. For those of you who are here Tuesday, similar framework, same 5 bubbles. What surprised you overall about the session? What your biggest concern is about heat pump water heaters? And what's your next step in order to prepare for putting heat pump water heaters in your next building? And then what's your main concern about improving hot water distribution? And what's the next step that you feel like you need to take in order to make that a reality? So if you want to jump over to the mural again, to the whiteboard, and get busy, we'll take a few minutes. I'm just going to leave it open this time. We put everybody on private on Tuesday, but I think actually it's probably inspirational for people to see what other people are saying. So I'm just going to keep the board open. So we're going to take just about 5 or 10 minutes at the most on this. We'll see how the flow goes.
Yeah, you know, Alistair, one thing we didn't dwell on, you know, we talked a lot about pipes, water pipes, and how knowing the loads can really help inform that. You know, one thing we didn't talk about was electrical infrastructure needed to support these systems. And that being another piece of this, you know, right sizing. We've seen a number of projects that, you know, trying to make this decision really early on, and the electrical engineer being very conservative, you know, rather than looking at equipment and design to inform that impact.
Yeah, that's a great point, because I assume if there's the load from the heat pumps, but then there's also some electric resistance backup, or at least swing tank. It has to be.
Yeah. I mean, and those are design parameters. You know, some Ecotope has examples of owners that wanted full redundancy. You know, if all of the heat pumps don't work, I still want to have hot water. Yeah. And that's a pretty substantial cost impact, and you know, both for the equipment but also the electrical service. So and I think there's ways to mitigate that. I mean, there's the heat pump. There's enough heat pump projects now for I believe to get the comfort level that they work if properly designed and commissioned. So.
Yeah, that's a great point. So I see, when I bounced everybody over here, I didn't point out that you can grab a sticky note from the left that represents the color coding for your discipline and add notes there. I think 1 or 2 people have just figured out how to create their own notes, which is great. That's fine too. But just wanted to point out there are piles of sticky notes over on the left you can use. Yeah, interesting, in the surprise me column, I think both of those things are quite revealing. I think it's true for a lot of people that nobody really thinks about the complexity of those systems. And I think, you know, for a lot of people, understanding how much of the energy goes into hot water has been something that's been buried until quite recently.
Mm-hmm. Yeah, one of the things that I've heard a concern from engineers is, downsizing pipes is really hard to fix, as you pointed out.
Yeah.
And, so it'd be great to have more data. And the task force has talked with SPU, for example, of trying to get more meters installed to get those curves that we looked at for a lot more buildings.
Yeah.
There's nothing that would stop an owner from trying to do that themselves if they have portfolio buildings to get that data. Maybe working with the utility or working with us to try and advocate to make that not a huge cost. Just given the savings that the funders could realize by having every affordable project use these methods, seems like it might pay for some research.
Yeah, that's a great point too. And while it's not quite clearly framed in the questions here, if people have specific thoughts, not necessarily about what their main concern is, but ideas of how we might help address that concern, that would obviously be relevant as well. Okay. So, as with Tuesday's session, we're coming on to the last 5 minutes or so here. And while I had a plan to do a little prioritization, I think the participation here is at a level that we probably don't need to dot vote, particularly on this. So I think we'll skip that piece of it. I wonder at this point, with just a few minutes left, if actually we might open the mics up for a little while. If anybody wants to unmute, if they have any particular observations that they want to share from this session, I think now would be an appropriate opportunity if anybody's got any specific questions that we can either answer now as clarifications or can carry forward to the office hour sessions, or just if they have observations about where they feel they're at in this process on this particular topic.
Or feel free to use the chat as well.
Yeah, yes, or use the chat if you prefer. Stunned silence.
I see a reflection about the cost of electricity and how it's low now, but going up. And if we, will cost rise faster if without diversity of fuel. So, that's a really challenging question, obviously. But I think the costs, it seems to be a commitment to try and make it affordable still. As we make these transitions, there's been a lot of work to recognize that affordability is really important. We're going to make these goals as well. And that you mentioned in the beginning, the climate crisis, but Exemplary Task Force, also is trying to balance that with the affordability crisis and housing crisis. So
yes,
it is something that we just need to continue to work on.
Yeah, for sure. And there's a lot of tough conversations there. I mean, obviously, the electricity market is a regulated marketplace, so that provides some assurance. But there are obviously delivery realities, and if the demand does outstrip the supply as we move towards a zero carbon grid, what does that look like? And clearly that brings up discussion about what happens with nuclear fission, and is there any possibility of nuclear fusion in order to try and bridge the gap more quickly than we might be able to with renewable sources, whether it's solar or wind or tidal power. I think those are big questions. I mean, I think there's a lot of exciting stuff starting to happen around hydrogen. A couple of interesting things I've seen recently about combined gas generating facilities retooling themselves to produce hydrogen. So to be able to take surplus electricity off the grid when it's not needed, to make hydrogen and store it and then burn it in their previously natural gas-based turbines. So there's a lot of interesting stuff happening in that field that obviously has got to get answered in order to manage that market cost issue. Anyway, we could get off on that tangent. Seems like things have settled down here, so thank you all for contributing and giving us some feedback on how you're feeling about this session. I'm just going to jump back quickly to a closing slide. The Exemplary Building Program guidelines are available here. I'm not sure if that link went in the chat this time, but if you go to the Exemplary Building, the HDC website, the Exemplary Building site, you can find all the guideline documents and the charrette decks and a whole range of great resources there. And the Domestic Hot Water Guideline will be published there. And I'm sure we'll figure out a way to send that out to all of the people who registered for this session. The office hours sessions will follow up over the next several weeks. As I say, at least one of them will wait until after the guidelines are published so that we can answer questions that come from reading those guidelines. There will be a SurveyMonkey evaluation that'll come out to everybody following this session. If you didn't pre-register, if you would drop an email to Lauren at housingconsortium.org with your email address so that she can add you to that distribution, that would be great. We are producing an asynchronous version of this training, so it can be done as an on-demand webinar, and we have an opportunity to tweak things. So if you have feedback, that's a great opportunity to provide that to help craft how it looks going forward. And we may deliver it again, hopefully, to groups that maybe include plumbing engineers and designers. And then finally, we do have operations and maintenance and resident engagement training session planned for the spring of next year, also related to exemplary buildings. And so that'll be something to look out for, and you'll be notified once that gets scheduled. Thank you all again, really appreciate your attendance today, the input, and look forward to hearing more from you on this topic. And I wish you the best rest of the day.